Welcome to my channel. Today I will discuss here the Astable Multivibrator. Astable means not having any stable state. No state is stable. Okay, that the output voltage, it cannot stay at any fixed level indefinitely. That is no state is stable one. Moreover here, no external triggering pulse is required. It is free running multivibrator. It continuously swings back and forth to the value high level and low level, that is V saturation and minus V saturation. So that means it is free running multivibrator. So this is plus V saturation, minus V saturation, plus V saturation. It is swinging between the two values. And we are getting a square wave, is swinging between plus V saturation and minus V saturation, and we are getting a square wave. Okay. Now multivibrator can be employed with using 555 timer, using BJT, using op amplifier. We will discuss today here the multivibrator with the operational amplifier. Okay. Multivibrator with op amplifier. Now the circuit diagram. Here we are having an op amplifier, minus plus terminal output voltage. Negative and positive mean non-inverting. To the non-inverting, there are the two resistors, and output is connected with it, with R1 and here R2, and then this ground terminal. Okay, now there's a feedback resistor, that is R, and here's a capacitor. The other end is grounded. Okay, here the value is Vp. And what is the value of Vp now? There's a problem. Now what's the current flowing here? Current is by Ohm's law, output voltage over the resistors. And how much the current develops a voltage across R2. So I into R2, substituting the value of I here, okay, we'll get the value of Vp, the voltage at the non-inverting terminal, that is Vp. Now what is the principle? The principle is op amplifier act as a comparator here. You know what the meaning of the comparator, like the op having minus plus terminal, like the two supply plus VCC and minus VCC, V1, V2 input, V0 is the output. And open loop mean that the gain is infinity. It is ideal case, but practically the gain is too much. Gain is very, very, very large. Practically it is very large. Okay, what happens? Now, comparator mean if, let by chance, V1 is greater than V2, mean voltage at minus terminal is greater, then output attains the value of minus V saturation. And if V2 is greater than V1, then output attains the value of plus V saturation. So the output swings depends upon whether V1 is greater than V2 or V2 is greater than V1. So this is a zero level. So if V2 is greater than V1, it goes to plus V saturation, and if V1 is greater than V2, it goes to negative minus V saturation. So output is like a digital having the two levels only. So it depends which voltage is greater. Now this is the op amplifier as a comparator having the two levels. Okay. Now this is a circuit diagram, and to start with, the op amplifier always gives some offset voltage even in the absence of any input signals. Even in the absence of any inputs, even then the op amplifier gives some offset voltage, and that voltage is usually very, very small. Now let it is V offset. Now in the presence of V offset, what will be the value of Vp? Vp will be equals to this into V offset. So Vp means there is small positive voltage at the non-inverting. So what happened? At the inverting it is 0 because it's grounded. There is a capacitor and grounded, and there is a small positive voltage at the plus terminal. That means at the two input there is a small difference voltage, and like op amplifier is basically a difference amplifier, so it amplifies the difference. So the difference will be amplified by the op, and the op amplifier attains its value plus V saturation. When it attains the value of plus V saturation, what happens? Vp also increases, but it doesn't. It not cause the increase in now V naught, because maximum value of V naught is V saturation. Already op attained this value, V saturations. So the output cannot increase further, even at the plus terminal, if the voltage becomes greater, but output remains plus V saturation. Now what happens? Charging of the capacitor starts. As the capacitor, as it starts charging, what happens? V1 starts increasing, okay, with the charging of the capacitor. As V1 starts increasing, a stage will reach when V1 becomes slightly greater than the value of Vp. When it becomes slightly greater than the value of Vp, what happens? Then the op amplifier output of the op, it jumps from positive saturation to negative saturation, because now V1 is increased than V2. If V1 is increased than V2, then op amplifier attains the value of negative V saturation. That means op amplifier switches from positive V saturation to negative V saturation. Okay, when there is a negative V saturation, what happens? Vp now becomes negative. Mean here Vp becomes negative. Mean Vp is a low potential now. As Vp is low potential, okay, and now what happens? So this is plus V saturation, negative V saturation, and because now the capacitor is already charged, but when the output is at negative V saturation, what happens? Capacitor starts discharging itself. Vp is at low potential. Now capacitor starts discharging. As the capacitor discharge, what happens? The potential at the point A, okay, potential V1 go on decreasing, and again a stage will reach when V1 becomes slightly less than Vp. When V1 becomes slightly less than Vp, okay, so capacitor starts discharging, and stage will reach when V1 becomes slightly less than Vp. What happened? Now because the potential at the plus terminal is greater, now again op amplifier jumps back from negative V saturation to positive V saturation. Okay, so this is already, it was negative V saturation. Now because Now the potential at point at plus terminal is greater, so it jumps to plus V saturation. This process repeats on again and again, and we'll get a square wave exactly, okay, with the help of the op amplifier without any triggering pulse, right? Now this is, positive V saturation already, and capacitor starts charging, and when the capacitor voltage becomes slightly greater than Vp, what happens? Then it jumps from positive V saturation to negative V saturation. Now what happens? The capacitor starts discharging, and when the potential becomes low, then Vp minus Vp, what happens? It jumps back from negative V saturation to plus V saturation. So this process repeats on again and again, and will get a square wave. Okay, thank you very much. Please subscribe my channel.